You deployed your app with multiple pods. Everything looks fine on paper, but when you check the cluster, one node is overloaded, one zone has most of the pods, and another zone is almost empty. Now think about this. If that busy node dies, or that zone goes down, your app loses a big chunk of capacity. So what do you do in this situation? This is exactly where Pod Topology Spread Constraints comes in. It tells Kubernetes, do not dump all my pods into one place. Spread them out properly. Instead of letting the scheduler pack everything into a few nodes or a single zone, you can control how evenly the pods are distributed. To understand this feature, you need one important term, topology key. A topology key tells Kubernetes what kind of bucket it should spread pods across. That bucket could be a zone, a region, a node, or even a custom label you define yourself. So topology key is basically the answer to this question. Across what should I balance these pods? The most common one is topology.kubernetes.io/zone. This means Kubernetes spreads pods across availability zones. If your cluster has 3 zones, Kubernetes tries to avoid placing everything in just one of them. Why is this useful? Because if one zone fails, your whole application does not disappear. You still have pods running in the other zones. This is one of the most important features for high availability. Another possible topology key is topology.kubernetes.io/region. This is a bigger boundary than zone. Use this when your setup spans across regions. For example, one region could be in India and another in Singapore. This matters in disaster recovery setups where you want workloads spread across geographic locations. A very common node-level topology key is kubernetes.io/hostmate. This means Kubernetes spreads pods across individual nodes. So instead of placing multiple replicas on the same node, it tries to distribute them across different nodes. This is useful when you want to avoid losing too many replicas if a single node fails. In EKS, you may also see labels related to node groups. A node group is a set of nodes managed together. These may use different instance types, different scaling behavior, or different cost profiles. Spreading pods across node groups helps avoid putting all your workload into one group only. Another useful key in EKS is capacity type. This can separate spot nodes and on-demand nodes. This matters because spot instances can disappear suddenly. If all your pods are on spot capacity, one interruption can hurt badly. Spreading pods across spot and on-demand gives you better safety. You are not limited to the built-in keys. You can use custom labels too. For example, you could spread by rack, hardware type, SSD versus HDD, or any custom grouping your infrastructure uses. This is especially useful in on-prem systems or specialized setups. Let us take the most important example, availability zone. Suppose you have 3 zones, Zone A, Zone B, and Zone C, and you want 6 pods. If you set topology spread with a max skew of 1, Kubernetes tries to keep the pod count nearly equal across the zones. So the ideal result becomes 2 pods in Zone B, 2 pods in Zone C. That way, no single zone carries all the load. Now, if one zone is already full, Kubernetes will try to place the next pod in the zone that has fewer pods. And if it cannot satisfy the rule and you use do not schedule, it will not place the pod at all. That is strict scheduling. So now you know how Kubernetes spreads pods across zones, nodes, and other topology buckets. But this is only one part of the story. The next question is, what is affinity in Kubernetes? That is what we will cover in the next video. Subscribe,